The testing facility outside Tokyo was eerily quiet as I walked through the gates on a cold morning in November 1943. I was Major Takeshi Yamada, Chief Small Arms Engineer for the Imperial Japanese Army, and I'd been summoned for what my superiors described as an urgent assessment. The war in the Pacific had been raging for 2 years, and our forces were reporting disturbing trends from the front lines. American troops seemed to possess a firepower advantage that our soldiers couldn't match. I'd heard the reports, of course. Every engineer in the Weapons Development Division had heard them. Stories of American infantry squads laying down withering fire that overwhelmed Japanese positions. Accounts of battles where our troops, armed with the venerable Type 38 Arisaka rifle, found themselves outgunned by enemy soldiers who could fire faster, reload quicker, and maintain sustained fire rates that seemed impossible. But reports from the field were often exaggerated, colored by the chaos of combat and the natural tendency of soldiers to emphasize the capabilities of their enemies. I needed to see the evidence myself, to conduct proper scientific analysis before drawing conclusions. Colonel Hideki Nakamura met me at the entrance to the testing range. He was a career infantry officer, a veteran of campaigns in China and the early Pacific battles, and his face bore the weathered look of a man who'd seen too much combat. "Major Yamada," he said, returning my salute. "Thank you for coming on such short notice. What I'm about to show you may change your understanding of why we're losing engagements we should be winning. With respect, Colonel, I've seen captured American weapons before. The M1903 Springfield is a fine rifle, but not significantly superior to our Type 38. Not the Springfield," Nakamura said grimly. "Come with me." He led me to a shooting range where several items were laid out on tables: rifles, ammunition, targets, and testing equipment. But what caught my attention immediately was a rifle unlike any I'd seen before. It was longer than our standard infantry rifle, with a distinctive profile and what appeared to be a clip-fed mechanism. "This," Nakamura said, picking up the weapon, "is the M1 Garand, the standard-issue rifle for American infantry. We captured several dozen of them from Marines on Guadalcanal, along with substantial ammunition stocks. I want you to test this weapon and compare it directly to our Type 38. Then tell me why our troops are reporting that they're being systematically outgunned." I took the rifle from him, examining it with professional interest. The construction was immediately impressive. Machined steel components that fit together with precision, a gas-operated action that suggested semi-automatic fire, and an 8-round internal magazine loaded via N-block clips. The weight was substantial, perhaps 9.5 pounds fully loaded, compared to our Type 38's 8 pounds. "Semi-automatic," I observed. "That would explain increased fire rates. But surely the complexity makes it prone to malfunction." "Test it yourself," Nakamura said. "I've arranged for a full day of comparative testing. Fire both weapons under identical conditions. Document everything. Then tell me what our infantry is facing." I spent the next hour familiarizing myself with the M1 Garand's operation. The mechanism was ingenious. Gas from a fired round was ported off from the barrel to drive a piston that cycled the action, ejecting the spent case and chambering a fresh round automatically. The shooter only had to pull the trigger for each shot. No manual bolt operation required. The Type 38 Arisaka, by contrast, was a traditional bolt-action rifle. After each shot, the shooter had to manually work the bolt, lift, pull back, push forward, lock down, before the weapon was ready to fire again. It was a reliable system, proven over decades of use, but inherently slower than a semi-automatic action. I loaded 8 rounds into the M1 Garand's internal magazine via the distinctive N-block clip, feeling it snap into place with a satisfying click. Then I loaded 5 rounds into the Type 38's integral magazine, working each round individually into the weapon as was standard procedure. The first test was simple: rate of fire against stationary targets at 100 meters. I shouldered the Type 38 first, settling into a comfortable shooting position. The rifle was familiar, its operation second nature after years of experience with similar bolt-action designs. I fired, worked the bolt, fired, worked the bolt, maintaining a steady rhythm. In 30 seconds, I'd fired all 5 rounds and the magazine was empty. 5 rounds in 30 seconds, 6 seconds per shot, accounting for aim and bolt operation. Then I tried the M1 Garand. The difference was immediate and shocking. I shouldered the weapon, acquired the target, and began firing. Each trigger pull produced a shot, with the weapon automatically cycling between rounds. No bolt to work, no interruption in my sight picture, no break in my shooting rhythm. The rifle bucked against my shoulder with each shot, the gas system absorbing some of the recoil, and I simply kept the trigger moving. 8 rounds in 12 seconds. Less than 2 seconds per shot, with room for improvement as I became more familiar with the weapon's characteristics. I lowered the rifle, my mind already calculating the implications. The M1 Garand had delivered 60% more rounds in less than half the time. An American soldier with this weapon could maintain a sustained fire rate nearly 3 times that of a Japanese soldier armed with the Type 38. "You see the problem?" Nakamura said quietly. It wasn't a question. "This is one shooter under controlled conditions," I said, trying to maintain objectivity despite what I'd just experienced. "In actual combat, with stress and movement and—" "Test it under combat conditions then," Nakamura interrupted. "That's why you're here. I need you to document exactly what our troops are facing so we can develop countermeasures or—" He paused, his face grim. "Or at least understand why we're losing so many engagements." Over the next several hours, I conducted increasingly complex tests. I fired both weapons while moving, while prone, while transitioning between targets. I tested them after exposure to sand, water, and mud, conditions common in Pacific Island fighting. I measured accuracy at various ranges, reliability after extended firing sessions, and ease of maintenance. With each test, the M1 Garand's advantages became more apparent. Reloading speed was particularly significant. The Type 38 required manually loading individual rounds into the magazine, a process that took a skilled shooter at least 15 seconds to complete a full reload. The M1 Garand's aim-block clip system allowed a reload in under 5 seconds. Simply insert the clip, and the action automatically chambered the first round. In a firefight, those 10 seconds of difference could be fatal. I conducted a specific test to measure this advantage under simulated combat conditions. I set up multiple targets at varying distances and timed how long it took to engage all of them with each weapon system, including necessary reloads. With the Type 38, I fired 5 rounds, then had to pause for 15 seconds to manually load another 5 rounds before continuing to engage targets. The total time to engage 12 targets was nearly 2 minutes, with significant gaps in my ability to deliver fire. With the M1 Garand, I fired 8 rounds, reloaded in under 5 seconds, fired another 8 rounds, reloaded again, and engaged all 12 targets in approximately 45 seconds. Not only was I faster overall, but my ability to maintain continuous pressure on the enemy was dramatically superior. The tactical implications were staggering. In a firefight, the ability to maintain continuous fire meant the enemy had less opportunity to move, return fire, or reorganize. Those gaps in firing, the 15 seconds it took to reload a Type 38, were windows where American troops could advance, take better positions, or coordinate their own fire. With the M1 Garand, those windows barely existed. Accuracy was comparable between the two weapons at standard infantry combat ranges. Both were capable of hitting man-sized targets reliably out to 300 meters. But the M1 Garand's semi-automatic action allowed for faster follow-up shots, meaning that even if the first round missed, a second and third could be fired before the target had time to take cover. I tested this advantage specifically by engaging pop-up targets that appeared for only a few seconds. With the Type 38, I could typically get 1, maybe 2 shots at a target before it disappeared. With the M1 Garand, I could fire 3 or 4 times at the same target, dramatically increasing the probability of a hit. The reliability testing produced results that troubled me even more. I'd expected the complex gas-operated mechanism of the M1 Garand to be prone to malfunction, especially under harsh conditions. But the weapon performed flawlessly through every test. I subjected it to sand, mud, and water, the kind of conditions that defined Pacific Island combat, and it continued to function reliably. I immersed the rifle in muddy water, let it dry with dirt caked in the action, and it still fired without hesitation. I exposed it to salt spray and humidity for several days, simulating the corrosive marine environment of island combat, and found only minor surface corrosion that didn't affect function. The Type 38, while also reliable, offered no advantage in this category. The gas system of the M1 Garand, which I'd assumed would be a weakness, actually proved remarkably robust. The design incorporated enough clearance and tolerance that fouling and debris didn't prevent operation. American engineers had clearly designed this weapon with field conditions in mind. By mid-afternoon, I'd accumulated enough data to draft a preliminary report. The conclusions were inescapable and deeply concerning for our war effort. Colonel Nakamura found me in the office adjacent to the testing range, reviewing my notes and calculations. "Your assessment?" he asked. I chose my words carefully. The M1 Garand represents a generational leap in infantry small arms design. In terms of sustained fire rate, it provides approximately 3 times the capability of our Type 38. In terms of reloading speed, approximately 3 times faster. In terms of reliability and accuracy, comparable or slightly superior. In practical terms, a single American soldier armed with this weapon possesses the firepower of approximately 3 of our soldiers armed with Type 38 rifles. Nakamura's face remained impassive, but I saw something in his eyes, confirmation of what he'd already suspected, what the casualty reports from the front had been telling him for months. 3 to 1, he repeated. So a 10-man American squad effectively has the firepower of 30 of our troops. In terms of sustainable rifle fire, yes, that's a conservative estimate based on controlled testing. In actual combat, the psychological impact of facing such high-volume, accurate fire may amplify the advantage even further. Our troops would be forced to take cover more frequently, reducing their own ability to return fire effectively. I paused, then added what I considered the most critical observation. Colonel, this isn't just about raw numbers. The continuous nature of fire from semi-automatic weapons changes the tactical dynamic entirely. With bolt-action rifles, there's a rhythm to combat. Fire, work the bolt, fire again. Both sides experience this rhythm, but with the M1 Garand, American soldiers can maintain almost continuous fire. They can suppress our positions while maneuvering, something that's extremely difficult with bolt-action rifles. The tactical flexibility this provides is perhaps even more significant than the raw increase in fire rate. Can we produce a similar weapon? Nakamura asked. Can our industry manufacture a semi-automatic rifle in sufficient quantities to equip our forces? This was the question I'd been dreading. I'd spent years in Japan's weapons development programs. I understood our industrial capabilities and limitations intimately. No, sir, not in the time frame relevant to this war. The M1 Garand requires precision manufacturing, advanced metallurgy, and production techniques that our industry is not currently capable of implementing at scale. We're already struggling to produce sufficient quantities of our existing weapons. Retooling to manufacture a completely new, more complex design would take years and resources we don't have. I explained further. The M1 Garand has several components that require precision machining far beyond what we're currently doing. The gas system components, the operating rod, the trigger mechanism, all of these need to be manufactured to very tight tolerances to function reliably. Our production facilities are geared towards simpler bolt-action designs. Even if we had the technical drawings and understood the metallurgy completely, we'd need to build new production lines, train workers in new techniques, and solve numerous manufacturing challenges. This would take a minimum of 3 years under ideal conditions, and our current industrial situation is far from ideal. Then what do you recommend? I thought carefully before responding. We need to develop tactics that mitigate the American firepower advantage. Emphasis on night attacks, where their superior fire rate is less decisive. Prepared defensive positions with interlocking fields of fire, where our troops can maximize the effectiveness of bolt-action rifles. And we need to be honest with our commanders about what they're facing. American infantry doesn't just have better training or higher morale, they have a decisive technological advantage in their primary weapon system. Nakamura nodded slowly. I'll need your full report in writing. The General Staff needs to understand the scope of this problem. Over the next week, I prepared the most comprehensive analysis I'd ever written. I documented every test, included detailed comparisons, and provided tactical recommendations based on the capabilities gap I'd identified. The report was technically precise, professionally objective, and devastating in its conclusions. I included specific sections on various aspects of the comparison. Fire rate analysis documented that trained shooters could fire the M1 Garand at rates of 40 to 50 rounds per minute sustained, compared to 15 to 20 rounds per minute with the Type 38. This wasn't just theoretical. I'd conducted extended firing sessions to measure fatigue effects and sustained performance. Reload time studies showed that under stress conditions, simulated by requiring shooters to move between covered positions, the M1 Garand's reload advantage actually increased. Soldiers could reload while moving with minimal interruption to their defensive awareness, while Type 38 reloading required more attention and time. Tactical scenarios. I developed several combat scenarios and wargamed them with different weapon systems. In every scenario involving sustained firefights, the force equipped with M1 Garands held decisive advantages in their ability to suppress enemy positions and maintain fire during maneuver. The response from the General Staff was complicated. Some officers accepted the findings and began incorporating them into their tactical planning. Others dismissed the report as defeatist, arguing that superior Japanese fighting spirit would overcome any technological disadvantage. A few questioned whether the tests had been conducted properly, suggesting that perhaps I'd made errors in my methodology. I was summoned to present my findings to a gathering of senior officers in December 1943. The room was full of men whose uniforms bore the ribbons of China, Manchuria, and the early Pacific campaigns. Men who'd built their careers on the superiority of Japanese military tactics and spirit. I presented the data dispassionately, allowing the numbers to speak for themselves. Fire rate comparisons, reload time measurements, reliability statistics, tactical simulations showing how American squads could deliver overwhelming firepower against Japanese positions. When I finished, the questions began. "Major Yamada," General Tanaka said, his voice heavy with skepticism, "you're suggesting that a single American soldier is equivalent to 3 of our troops? That's absurd on its face. Not equivalent as soldiers, General. Equivalent in terms of sustained rifle firepower. The data is clear. Data from controlled tests," another officer interrupted. "Combat is not controlled. It's chaotic, unpredictable. I question whether these theoretical advantages translate to actual battlefield conditions. Sir, the casualty ratios from Guadalcanal, New Georgia, and Tarawa support the conclusion that American infantry possesses significantly greater effective firepower than our own. The M1 Garand is a major factor in that disparity." The debate continued for hours. Some officers grudgingly accepted the evidence. Others clung to the belief that Japanese tactical superiority and fighting spirit would compensate for any technological disadvantage. The meeting ended without clear consensus, though my report was officially acknowledged and filed. But word of the testing spread through the engineering and tactical communities. Other engineers requested access to the captured M1 Garands for their own evaluation. Every test produced the same conclusions I'd reached. The weapon represented a significant advancement over bolt-action rifles, and our troops were facing a serious disadvantage. Captain Kenji Sato, an engineer from the Kokura arsenal, conducted his own independent testing and reached conclusions that mirrored mine. "The Americans have industrialized warfare at a level we haven't matched," he told me during one meeting. "The M1 Garand isn't just a better rifle, it's a product of an entire industrial philosophy that prioritizes equipping soldiers with the best possible tools. We've focused on producing adequate equipment in large quantities. They've focused on producing superior equipment in large quantities. That difference is showing on the battlefield." In January 1944, I was assigned to lead a project developing countermeasures and tactical recommendations for infantry units facing American forces. It was an acknowledgement, however indirect, that the General Staff recognized the problem even if they wouldn't publicly admit its scope. I worked with combat veterans, gathering first-hand accounts of engagements where American firepower had been decisive. The stories were remarkably consistent. Japanese forces would initiate an attack or defend a position, and American troops would respond with devastating volumes of accurate rifle fire. Our soldiers, limited by the slower rate of fire inherent in bolt-action rifles, found themselves unable to suppress American positions effectively. One sergeant from the fighting on Bougainville described it vividly. "We attacked an American position with 30 men. The enemy had perhaps 10 soldiers. We expected to overwhelm them quickly, but they opened fire with such intensity that we thought we were facing a much larger force. Our men couldn't advance. Every time someone tried to move, multiple shots would come from the American positions. The fire was continuous, never stopping. With our rifles, we fire, work the bolt, fire again. There are gaps, but their fire never stopped. We lost 15 men before we were forced to withdraw. 15 men against 10, and we were driven back by their firepower." Another veteran, a corporal from fighting in the Solomon Islands, provided additional perspective. "The worst part wasn't just that they could fire faster. It was that they could keep us pinned down while their other soldiers moved. With our Type 38s, if we tried to provide covering fire, we could only shoot so fast. They'd wait for the gaps when we were working our bolts, then they'd move. But when they provided covering fire for each other, there were no gaps. Just continuous fire that made it impossible to raise your head. It completely changed how combat worked. The tactical recommendations I developed focused on methods to negate the American advantage. Night attacks, where visibility limited the effectiveness of rapid rifle fire. Emphasis on close-quarters combat, where the engagement ranges didn't allow American troops to exploit their firepower advantage. Improved camouflage and concealment techniques to reduce the number of targets American riflemen could engage effectively. I also recommended concentrating our automatic weapons, light machine guns and grenade launchers, to provide suppressive fire that could compensate somewhat for our rifle disadvantage. If we couldn't match American rifle firepower, we needed to maximize our crew-served weapons to even the tactical equation. But these were mitigation strategies, not solutions. The fundamental problem remained. American infantry carried a weapon system that was simply superior to ours, and our industrial capacity couldn't produce an equivalent in meaningful numbers. I continued testing captured American weapons throughout 1944, expanding beyond just the M1 Garand to include other systems. The M1 carbine, a lightweight semi-automatic rifle issued to officers and support troops, further extended the American firepower advantage. Even American officers and rear echelon troops had semi-automatic weapons, while our officers carried pistols and our support troops often had older rifles. The Browning automatic rifle, which equipped American squads with a fully automatic support weapon, added another layer of capability we couldn't match. Our Type 96 and Type 99 light machine guns were comparable in some respects, but the Americans had both superior squad automatic weapons and superior individual rifles. We had to choose where to allocate our limited automatic weapons. They had firepower advantages across their entire infantry organization. Each test, each analysis, reinforced the same conclusion. American infantry was better equipped than Japanese infantry, and that equipment translated directly into battlefield effectiveness. In March 1944, I was present when several officers from the General Staff came to observe live fire demonstrations. I'd arranged a side-by-side comparison, teams of soldiers firing Type 38 rifles against targets, then teams using captured M1 Garands against identical targets. The visual difference was stark. The bolt-action rifles produced a steady, rhythmic fire, crack, pause, crack, pause. The semi-automatic rifles produced a continuous stream of fire, crack, 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 one shot flowing immediately into the next. General Hasegawa, who'd been particularly skeptical of my earlier reports, watched in silence. When the demonstration ended, he approached me. "Major Yamada, I owe you an apology. I doubted your findings. I believed you were overestimating the American advantage." He gestured toward the targets, now thoroughly shredded by the M1 Garand fire. "But seeing the difference with my own eyes, we've been sending our troops to face this?" "Yes, sir, for 2 years now. And we can't produce similar weapons? Not in the quantities needed. Not with our current industrial capacity. We'd need to fundamentally retool our small arms production, which would mean temporarily reducing output of existing weapons. Given our strategic situation, that's not feasible." Hasegawa nodded slowly. "Then we fight with what we have and hope our tactics can compensate." He paused, then added quietly, "Though I suspect you and I both know how that story ends." I said nothing. There was nothing to say. The testing and analysis continued through 1944 and into 1945. Each captured American weapon told the same story. Our enemy had invested heavily in equipping their infantry with modern, effective small arms, while our own troops made do with weapons designed decades earlier. The Type 38 Arisaka was not a bad rifle. It was accurate, reliable, and had served well for many years. But it was a product of an earlier era of warfare, designed when bolt-action rifles were the standard for all military forces. The world had moved on. The Americans had moved on. We had not. By late 1944, I was also analyzing reports of American tactics that exploited their firepower advantage. Their infantry squads would advance in small groups, with some soldiers providing suppressive fire while others moved. The high rate of fire from their M1 Garands allowed even a few soldiers to pin down larger Japanese forces, while their companions maneuvered for better positions. Our troops, limited by slower-firing bolt-action rifles, struggled to provide effective suppressive fire. Attempting to suppress an American position required more soldiers firing simultaneously, which meant fewer soldiers available for maneuvering. The tactical equation simply didn't work in our favor. I drafted report after report, each one documenting the growing evidence that the small arms gap was contributing significantly to our tactical difficulties. Some reports were well received, others disappeared into the bureaucratic machinery of the military, filed and forgotten. Lieutenant Colonel Hiroshi Tanaka, a tactical instructor, incorporated my findings into his training programs. We're teaching our officers to expect American infantry to have 3 times our firepower at the rifle level, he told me. It's affecting how we plan attacks, how we organize defenses. We're having to concentrate forces to achieve local superiority, which makes us vulnerable to American artillery and air power. The firepower gap at the small unit level is creating tactical problems that cascade through our entire operational approach. By early 1945, as American forces closed in on the Japanese home islands, the strategic situation had become dire. The question of infantry small arms seemed almost quaint compared to the larger problems we faced. Air superiority lost, naval forces decimated, industrial production collapsing under American bombing. But I continued my work because it was what I knew, what I could contribute. If Japanese soldiers were going to fight, they deserved to understand what they were facing. They deserved honest assessments from their engineers and tacticians, not comfortable lies about spiritual superiority overcoming material disadvantage. In April 1945, I was visited by a young lieutenant who'd just returned from fighting on Iwo Jima. He'd heard about my testing program and wanted to share his experiences. "Major, we were told that American soldiers were soft, that they'd break under pressure," he said, his voice bitter with the memory. "But when we attacked their positions, they cut us down with such firepower that we couldn't get close. Their rifles fired so fast, so continuously, that it sounded like machine guns. We lost half our company in the first assault. The survivors said they'd never faced anything like it." He continued, his words tumbling out as if he'd been holding them in for too long. "I watched my squad try to cross open ground to reach an American position. There were maybe 5 Americans in that position. 5? We had 20 men. But their fire was so continuous, so accurate that we couldn't advance. Every time a man stood to rush forward, shots would hit near him, forcing him back down. It wasn't like fighting against other bolt-action rifles, where there's a rhythm, pauses you can exploit. Their fire never stopped, never. And when we finally did reach their position, they'd already fallen back to another prepared position and did the same thing again." "I'm sorry," I said. "If our reports had been taken more seriously earlier in the war, perhaps better tactics could have been developed. With respect, sir, I don't think tactics would have made much difference. When the enemy can shoot 3 times as fast as you can, when they can reload in a third of the time, when every one of their soldiers has the firepower of 3 of yours, tactics only get you so far." He was right, of course. The M1 Garand represented not just a technological advantage, but a philosophical one. The Americans had recognized that firepower was decisive in modern warfare and had equipped their infantry accordingly. We had clung to older doctrines, believing that other factors could compensate for inferior equipment. The war ended in August 1945. By then, the small arms disparity that had troubled me since 1943 seemed like a minor footnote in the larger story of Japan's defeat. But it had been a contributing factor, one of many technological and industrial disadvantages that had accumulated to create an insurmountable challenge. After the war, I was interviewed by American military historians studying Japanese perspectives on the conflict. They were particularly interested in my testing program and the reports I'd generated. "Did your findings influence Japanese tactics?" one historian asked. "To some degree," I replied. "Some commanders took the firepower disparity seriously and adjusted accordingly. Others did not, believing that spirit and determination could overcome material disadvantage." "And in your professional opinion, how significant was the M1 Garand's advantage?" I thought back to all the tests, all the data, all the combat reports I'd analyzed. Very significant. Not decisive on its own. Wars are won by combinations of factors, not single weapons. But it gave American infantry a substantial edge in firefights, and over thousands of engagements, that edge accumulated into a meaningful advantage. The historian nodded, making notes. We've interviewed American veterans who said they felt outgunned when facing Japanese machine gun positions or artillery. It's interesting to hear that Japanese infantry felt similarly outgunned at the small arms level. War is often a matter of perspective, I said. But from a purely technical standpoint, the M1 Garand was superior to the Type 38 in almost every measurable category relevant to infantry combat. That's not opinion, it's engineering fact, supported by extensive testing. In the decades after the war, military historians would debate the factors that contributed to Japan's defeat. Most focused on the big picture: strategic mistakes, industrial capacity, resource shortages, air and naval power. The question of infantry small arms rarely featured prominently in these analyses, but I knew the truth. I'd seen it in the testing data, in the combat reports, in the faces of soldiers who'd survived engagements where American firepower had been overwhelming. The M1 Garand hadn't won the war for America, but it had given their infantry a decisive advantage in the basic task of putting accurate fire on enemy positions. Japan was stunned when our engineers tested US rifles and realized why our troops were outgunned. We'd gone to war believing in our own superiority, confident that determination and tactical skill would carry the day. Instead, we discovered that our enemy had equipped his soldiers with weapons that were simply better than ours, not marginally better, but substantially better. And our industrial capacity couldn't close that gap. It was a hard lesson, learned at tremendous cost. And it remained one of the most significant technical assessments I would ever conduct, the day I confirmed that our infantry was fighting at a decisive disadvantage, armed with weapons from an earlier era against an enemy that had embraced the future of infantry combat.